computer and how it differentiates from the other blockchains. I would just like to get a feel of the audience here. Like, if anybody could step up and say a few things about internet computer, what's your knowledge is so far based on the previous sessions you have? Anybody? Shijin, Noah, Wang?
Yeah, like internet computer is a decentralized cloud computer, and the mission is to bring the decentralized internet to the world and make the adoption of all the apps to the decentralized world. And the internet, anything on the internet, web, games, any applications that are right now on Web 2 can be transferred to Web 3 with help of ICB blockchain.
That's exactly correct. And I would just like to add a few more things here. So as you mentioned, internet computer is the new decentralized cloud, right? But first we need to check like why there is a need of a decentralized cloud in the very first place. So in 2008, when Bitcoin came out, we figured out that we could move money in a trustless manner where we do not need to rely on banks, a certain physical entity who controls everything. And then we basically have to ask them, hey, can we move our money from this account to that account, or to whom we can pay, to whom we cannot pay. So Bitcoin gave that vision how humans can basically interact with each other, especially in money movement form, without having a centralized country, a company, or a bank controlling us. Then in 2015, Vitalik took it one step forward, where we envisioned a world where we can even program certain things, certain softwares on the Ethereum blockchain, and that way those softwares are not controlled by a single company or a group of entities. The biggest classic example is the Uniswap exchange. On Uniswap exchange, you could basically trade between Bitcoin, Ethereum, and other tokens without a centralized company, allowing you, doing KYCs for you, and even restricting you in like various formats. Whereas in your traditional world or the centralized world, let's say if you would have opened up a account on Robinhood, where you are trading multiple stocks, these centralized companies have the ability for you to basically, whether you can trade it or not trade it. Last time, I think like 2 years back, something happened with GameStop and the AMC stock, right, where they delisted those stocks because the dumb money was buying those stocks, and the price was shooting over the roof. So that's what we saw with Ethereum, with the ability to program softwares on the blockchain itself. But then there are some limitations. Bitcoin and Ethereum both are ledger-based technologies, right? So whatever happens, we basically have an input, we have a program, we compute something, then there is an output, and ultimately we store everything in a block. And this block by block, all this forms is a ledger. For Bitcoin, for Ethereum, and per se any of the leading ledger-based blockchain technologies, even in top 10 or top 20, this ledger is basically shared with all the computer, whoever is running this blockchain code. And these computers, to be honest, are like very generic. These are probably the computers sitting at your home, or these are some of the virtual machines with a very standard config, which can only do limited amount of things in a limited amount of time. And since these are the ledger-based technologies, you have to have a copy of this ledger on every machine, right? And that increases cost a lot. Just to give an example, 2 years back, like in 2021, when I was doing a trade on Uniswap, one trade was costing me around $100 to $150, depending upon what time of day I was trading, because there was so much demand and it can only do limited stuff. That's why the cost of executing a transaction was very high on Ethereum. That's where Dominic realized there needs to be a not just a ledger-based technology. There is a need of a decentralized cloud platform itself, where people can deploy softwares, and people should be able to trust those softwares in a trustless manner. And that's why we have a internet computer blockchain here. I would call it more sort of a decentralized cloud, with all the capabilities of layer 1 and layer 2 blockchain, and we'll see like why it is the case with internet computer. So we'll dive deep into various features of internet computer. I'll not read through this slide, but there are certain interesting concepts. One is basically the 100% on-chain storage. Just to set your context here, even the NFTs which are minted on Ethereum, the image file for those NFTs are not stored on the Ethereum blockchain. They might be stored somewhere on the AWS or Google Cloud. And why that is problematic? For example, if I would have sold you my NFT, and tomorrow, if I don't pay for my storage on AWS and Google, ultimately you'll not have access to that image. What you'll have is just a raw record. Okay, this is the NFT, this is the name, this was the owner, this is how it traveled from the original minter to you. But the digital content of that NFT can get lost if you do not pay these providers, or if these providers decides to shut you down. That's where internet computer comes into picture, where you could also store images, audio files, video files, whatever content, digital content you can imagine, that can be stored on the internet computer because it's a decentralized cloud first. The second main feature of the internet computer is the end-to-end application, right? So even for the Uniswap is basically a smart contract. It's a program which will let you trade between two different tokens. But the UI of Uniswap, if you see, is not hosted on Ethereum network. The UI is hosted on global CDNs, might be on AWS or Google Cloud. We do not know. But when you write uniswap.org, it is going to a server, a centralized entity, which basically owns that front end, right? And how you can trust that particular front end. That front end can basically change code anytime, anything can happen. The DNS can be changed. So we really do not know when we are interacting with Uniswap smart contracts, unless and until you are a developer. You rely on uniswap.org and the good intentions of it, that website will not do anything malicious. On the internet computer side, apart from these smart contracts, you can also host UI on internet computer. And then the creator of the platform can just say, hey, now this website will not be changed. It cannot be altered, modified. Essentially, you make those websites and those smart contracts immutable. So they'll exist on the internet computer blockchain as long as the internet computer blockchain is alive, and any user can basically just interact with it. And then we'll touch base multiple aspects of what one could do with ICP token, what are Dows, what is this chain key cryptography, and how Bitcoin and Ethereum integration is coming into picture. Any questions so far? All right. So we'll just go with a few of the unique features why internet computer is better than other layer 1 blockchains like Ethereum, Cardano, Tron, Solana. So first is the proof of useful work. Now to understand this, we again need to go back to the concept of Bitcoin, right? How Bitcoin adds a new block into its blockchain. What miners and validators are doing on the Bitcoin network is they're just trying to solve a very complicated random mathematic puzzle. So for example, let's say there are 2000 miners on Bitcoin network. A random problem will be generated based on how many miners are there. The more the miners, the more the complex the problem is. And then everybody is just solving that mathematical problem. And whoever basically derives the output of that mathematical problem first gets a chance to add the block to the Bitcoin network. But what is the problem with that? Ultimately, you are doing a lot of useless work on the Bitcoin blockchain, which is not efficient, right? It is not carbon efficient. It is not energy efficient. It is also not time efficient. You are just trying to solve a complex problem. And that's where we talk about this proof of useful work on the internet computer blockchain, where instead of doing some sort of random solution to a mathematical problem, we are actually doing what is needed. What we are doing is we are executing those smart contracts, we are processing the input, and then we are figuring out the output, right? And that's the useful work which the internet computer blockchain do. And that also it does not do on a typical hardware. So let's say in the analogy to what the miners are called on the internet computer, they are called as node provider. A node is basically a computer, basically, but it's a complex computer. It's not a computer like my laptop or a normal virtual machine or a desktop which is at my home. These are specific high-grade industry hardware which are deployed in the data centers, and that is how you basically use all the computational capability of those hardwares to do this useful work. Coming to the second point, why it is extremely safe and reliable. I just answered this question, right? Because these hardware are like so efficient. These hardwares are placed in the data center. That's where you can 99.99% time count on this, that these hardwares will not go down. Whereas, let's say, if you're an Ethereum network, your home internet connections drop, you don't have electricity, you'll have a downtime in terms of like what you're doing, right? So internet computer provisioned by these dedicated machines in the dedicated data centers, they apparently gives you around zero significant downtime, which we have observed in the past 2.5 years. Probably this side needs some updation. And then, since we are not doing all this kind of random mathematical problem solution, we are doing the actual work, and scientists have certified this. This is the greenest blockchain out there in terms of the carbon neutral, right? Because you're not doing something which is not needed. Essentially, you're not consuming that much electricity. All the electricity what these machines are consuming in these sitting high data centers, they are doing, which is something really needed to be done. And that's where internet computer is not outputting out any of the carbon to our environment. And just to give you a context about this, if you transfer ICP between two person, you could essentially do two transactions for the same amount of environmental impact as you do one Google search on Google search engine, basically. And then we talk about last generation smart contracts. And by this, what do we mean is, I talked about the images, the videos, the audio files, everything, the need to be stored on the smart contract itself, right? Which Ethereum does not give. The smart contracts on internet computer blockchain gives you the ability that you can store the software as well as you can store the data as well. So for example, if you are creating or minting an NFT on the internet computer blockchain, it will have the NFT metadata, but as well as at the same time, it will have the digital content related to it as well. And it will live on the internet computer blockchain as long as the internet computer is alive, basically. Then we move to the other critical features of the internet computer blockchain. Since it is thought through, these are high grade performing hardwares in the data center. Essentially, what we have done is we have minimized the transaction cost. Remember, I mentioned when I was doing a trade on Uniswap in the peak of the bull market, a transaction was costing me $100. It will never cost you that much, and even not even $1 on the internet computer blockchain, because everything is like pre-calculated. We know these are the hardwares required, this is the cost to run these hardwares, and everything is baked into the protocol itself. So we have like predictable prices, and these prices are typically very, very, very low. The other unique feature of internet computer blockchain is the reverse gas model. If anybody of you would have interacted with Ethereum blockchain, you would have seen that the user, for example, me, when I'm trading on Uniswap, I am basically paying for the transactions to be executed on the Ethereum blockchain, right? And that's where I told you, like, when I was trading on Uniswap, I was paying out $100, $150 out of my own pocket, which is not the case on the internet computer blockchain. The developer, the creator of the project, initially funds all the gas fees or whatever fees which is required by the which is required by the protocol to execute the software. And later on, once these softwares matures, the control is given to the community in the form of SNS DAO, and then they have an inbuilt mechanism of pre-funding these smart contracts so that they can execute forever and eternity on the internet computer blockchain. So me as a user do not have to pay anything if I have to even trade on the internet computer blockchain, if I am visiting any social media website on internet computer blockchain, if I'm interacting with any of the DApp which you can imagine, a user does not have to pay to interact with the internet computer. And now talking about the cost, as we have seen on Ethereum, it would be very, very costly if somebody would have to store a 2 megabyte or 3 megabyte of file, right? Because it's a ledger-based technology, the ledger is replicated everywhere. On internet computer blockchain, These are highly specialized hardware sitting in the data center, which has ample amount of storage. Everything is thought through, and that's why the cost is too low as well. It just costs around like $5 for a gig of data to be stored on chain for a year. One of the critical functionality of internet computer blockchain is the HTTPS outcalls. What do we mean by that? So for example, if you would have created an application on Ethereum, Solana, Cardano, whatever blockchain, you cannot consume our traditional data. So for example, if you are creating an airline booking application or any other application which wants to consume, let's say, weather data, stock price data, or any of the data we have within our traditional systems, we cannot do it by the nature how the Ethereum smart contracts are designed. It has to be either done on the UI side, but again, UIs are stored on the centralized servers. Who would basically trust if the Web2 data we are consuming within our smart contracts can be trusted in a trusted manner or not? On internet computer, the smart contracts have the ability to make HTTP calls. These are just like normal GET calls, which you could make to Yahoo APIs, Bloomberg APIs, our weather channel apps, so that we can consume that data within our smart contracts itself. And none of the other blockchains come even close to this particular feature. You would have heard about a project called as Chainlink. Chainlink is a blockchain in it itself, which was just created to solve this HTTPS outcalls problem. So a smart contract on Ethereum will have to rely on a smart contract on Chainlink, which will essentially bring the Web2 data, and the Ethereum smart contracts can interact with it. So consider this, a whole blockchain just dedicated for this feature, and it's a feature in the internet computer blockchain. Now, as we talked about before, the end-to-end experience can be delivered by the internet computer blockchain. Why? Because we have the smart contracts, the logic, which is the backbone of any software hosted on internet computer. We have the data, the images, the files, the media, and everything that is also hosted on the internet computer blockchain. Also the UIs, basically the front end which we use to interact with these specialized smart contracts, that is also hosted on internet computer blockchain. So one could say we have hosted the full stack of our software on the internet computer blockchain. And if you make it immutable, you fund it with enough cycles, it will live for eternity on the internet computer. And that's the end-to-end Web3 experience, which internet computer right now is capable of delivering. You might contest me, hey Ritvick, why there are no other blockchains very similar to internet computer blockchain? And the reason is just this. So from Bitcoin to Ethereum, projects like Chainlink came, projects like Filecoin came. What is Filecoin? Filecoin is a distributed data storage chain, right? So they approached through that angle. Now they are bringing in the compute part of it as well. So everybody tried to approach it with a different angle, and internet computer had a bigger vision. Hey, why can't we just solve all the problems and deliver everything in one go? And that's why internet computer, if you would have heard about this, the concept originally rises in 2016 or 17. It took 4 years just to do mere research what we want to do, and now we have the final end-to-end product, which gives us a full stack end-to-end experience. I think I've already covered this, but the good part of hosting front end on the internet computer is that it is also searchable and discoverable by our traditional search engines. So if you go and figure out the best DEX decentralized exchange on ICP, if you search on Google, you'll directly find links to Sonic, Infinity Swap. These are the exchanges which are completely built online, and Google actually knows it. Whereas a smart contract on Ethereum, Google does not have any idea like what is the smart contract of Uniswap is. Google will know what is the front end of Uniswap is because that is hosted on AWS or GCP, but it doesn't know what exactly the smart contract on Ethereum is, which is known as Uniswap. So this is a great feature in terms of discoverability. Whereas normal people in the next bull run, they might be searching for, hey, what are the flagship games on ICP? What is the unique or the flagship decentralized exchange on ICP? Search engines will be able to index them and deliver it to their users. Any questions so far?
No one is fine. Thank you.
All right. Let's move on to the second aspect, which is the internet identity. Now, what is internet identity? I'll directly correlate this with MetaMask on the Ethereum side. So to interact with Ethereum smart contracts, you need a MetaMask a wallet, and essentially a wallet is a combination of public and private key pair. So you use that wallet to interact with Ethereum blockchain and any other sort of EVM compatible blockchains. We have a similar concept here on internet identity on the internet computer, and we call it internet identity. So, for example, as long as you do not want to publicly browse any social media website on ICP or even the decentralized exchanges, if you have to interact with that software, you'll have to create an identity, right? And you do not need a wallet for it. You can directly go to browser and create an internet identity, and that identity is only known by you. You know, I'm called 123 or XYZ. The software, the website will not know who you are basically. So you can use this identity to interact with the internet computer. So, for example, if you have to go to this particular website, we have Discover. Discover is the biggest social media platform on ICP. And if you want to create multiple profiles there, you'll post something daily. The internet identity is what you need basically to post something on Discover. The way to get started with the internet identity is, I think you'll go to identity.ic0.app and then you can basically create your own identity. And I think Javier will share this slide with you so you can follow these links if you just want to create your identity and try out few of the dApps on your own. Now let's talk about the governance and ICP token. And that's where we differentiate a lot from other blockchains in the ecosystem. Consider Bitcoin. On Bitcoin blockchain, you can only do one thing, right? You can send and receive Bitcoin with other parties, and that's the whole purpose of Bitcoin. On Ethereum, you could use Ethereum as a gas fee. You need Ethereum to interact with the smart contracts, as well as you can also send Ethereum here and there between multiple people. Now with proof of stake concept, Ethereum also migrated from proof of work to proof of stake, and then there are many other blockchains which are proof of stake, right? What they do is, so there are these validator nodes who are basically mining the blocks and maintaining the integrity of the network. But who gets to decide which validator will be part of the network, right? And that is directly correlated with the amount of Ethereum which is staked on that validator. So the more the stake on the Ethereum validator, that validator will take participate in validating the Ethereum network. Now, what's the downside of this? The downside of this is now there are companies like Coinbase, the biggest exchange in the United States, and Binance, the biggest exchange in the Southeast Asian region. What they have done is they have their own validators. They have these big products of exchanges, and they offer products like staking on their platform as well. So every common person who does not know how to run validator or how do I stake my Ethereum on my own, they just go on Coinbase and Binance and they stake with them. What that does is most of the stake actually piles up with Coinbase, Binance, and few other bigger exchanges. Now imagine an era where all these 5, 6 different entities they basically talk to each other and decide to take the Ethereum network down, or they decide to basically stop some of the smart contracts. This is very in anti-principle to a decentralized technology. And that is why on internet computer, the critical machines which are placed in the data centers, they do not have a staking concept. Those are different from the ICP staking concept. And the ICP staking concept is only for the governance of the internet computer protocol. By governance, I mean what will happen on the internet computer, what new features we want, but the machines who are doing the actual work, they are not part of the staking at all. So that is why we eliminate the problem of having these 5 or 6 centralized powerhouse. So in a nutshell, what we can do with ICP, we could basically use it to participate in the governance system. We could definitely use it like Bitcoin to pay each other. Also to pay these node machines, these specific machines which are in the data centers. Essentially, you use ICP to convert them to cycles. Usually developers convert them to cycles and pre-feed in the smart contract so that those smart contracts can execute the reverse gas model. This is exactly the same which I mentioned. ICP are converted to XTC. These are the cycles. And those cycles are basically the computational unit for everything to exist on the internet computer to run on the internet computer. Also, you can use these ICPs to invest in new projects which are coming along the way. So every other week, I think there is a new project raising some funds. These projects are by default decentralized autonomous organizations, and these projects raise funds. So you could definitely use your ICP to basically invest and participate in the development of those projects. So how to stake ICP, which is the utility token? I think anybody could go on nns.ic0.app and you'll use your internet identity to manage your ICPs and if you have to stake it or not. The good part of staking on ICP is, unlike Ethereum, if you have to participate in governance, you'll have to stake your ICP for at least minimum 6 months. If it is not staked for 6 months, you'll not get any rewards out of it. You'll also not be able to participate in the governance as well. So that's the minimum commitment what ICP needs. So only the interested parties, the people who really want to participate, they'll come and stake their ICPs. Unlike on Ethereum, I'll just stake, I'll forget, and I'll be making 5% yield every year. And essentially, the users do not even participate in the governance of the Ethereum ecosystem. Talking about Dows on ICP, I assume service nervous system, it's a very technical term. Even I do not agree with it, but think of it as a brain behind the DAO first architecture on ICP. So if you have to create a project, you do not have funds, rather than going to a traditional investor, you'll create your DAO, you'll create your SNS here, you'll raise some funds, and also the development of your project will be according to the protocol itself, right? So you'll allocate some funds. Those funds will be given to the developers, the creators. They'll create the software, and that software will be deployed on ICP network via this service nervous system. So it's not like if I have been contracted to develop a software on ICP, I could upload any software by my will. It has to go through this framework, so the quality of the software is controlled there.
Ritvick, we have a question in the chat.
Yeah. Oh, okay. Yeah, so to answer this very question, which part of ICP is the blockchain? So when I mentioned these smart contracts, we call it canisters, which have the ability to store the program, which has the ability to store the data, which also has the ability to store the front end. This canister is the very blockchain in the internet computer context. So whatever input you give to this canister, there is some compute which has happened, and then there is an output. And this output is basically recorded as a state machine. So you could, in the eternity, see what a smart contract would have done in its lifespan by seeing those states. And those states are known as the block. And the sequence of this block is the blockchain. Now, the Shijin has asked, like, my understanding is that the blockchain is a ledger. So on Ethereum, it's definitely a ledger, but ledger of what? Ledger of blocks. And what that block has, the block has, hey, if somebody would have transferred one Ethereum to someone else, that's the content of that block. Or if a computation has happened through a Uniswap smart contract or something, you'll have the input, you'll have the software, and then you'll have the output. And that output is basically stored on the block itself, right? On ICP, that is also achieved in a similar way via these canisters or these smart contracts, but it has a little bit of more of the capability there. For sure, you could just have a canister, which will just be a ledger canister. So if you just want to record, hey, what is happening in certain decentralized application, you could definitely just have a ledger of it, and we call it a ledger canister. Even in fact, the ICP movement, which is happening on the ICP blockchain, that is happening by a smart contract, and we call it a ledger canister there. Does that answer your question, Shujin? I assume it's a yes, and if not, then perfect. Shoot more questions there on the chat. So as we were talking about the the SNS, right? So the NNS and SNS are two similar terms. NNS is basically for the governance of the internet computer, whereas SNS is for the governance of any project which is being created on the ICB blockchain, whether it be Discover, whether it be Hot or Not, whatever. And essentially, what these two concepts help us achieve is they help us achieve the DAO first culture on the internet computer blockchain, where you will create a decentralized autonomous organization owned by a couple of different stakeholders. So let's consider the example of OpenChat DAO. When this DAO was created, a certain tokens were reserved for the liquidity, certain tokens were set aside for the dev team, certain tokens were aside for the seed founders, certain were aside for the community, the user reward. These are the stakeholders basically, right? So these are whoever owns this allocation of the token are essentially the owners of these DAO. Very similar to you buy a stock of Apple or Google, but then you are just a stockholder there, right? You do not have any say in the day-to-day operation of these companies. But here, the more the token you have, the more the voting power you'll have, and then you can influence the direction of the project there. And then there are like many applications which have been built over the past of 2.5 years on the internet computer blockchain. You could easily correlate most of the applications with the applications in the Web2 world. So there is Nuance, which is the equivalent of Medium. I'll cover some big ones. It's the Open Chat, which is in comparison to Telegram. Telegram today can decide to stop the accounts of certain users because they own it. If you have to stop an account on Open Chat, ultimately you'll have to create a proposal for it, and then whoever owns the Open Chat token will have to vote for it. And once that is done, then only you can ban an account. Otherwise, you could chat on Open Chat for the eternity, and for a user, you do not even have to pay for it. Other good example of the use case of Open Chat is even the creators of Open Chat do not have access to what me and Javier are talking on Open Chat. Telegram also claims this, WhatsApp also claims this, but they do have a key sitting on their server as well, for which if they have to basically see your messages, they can see it. But OpenChat is completely end-to-end encrypted. Even the OpenChat team does not know how to access your chat, and how we can be 100% sure about it, right? Since these are the DApps, their code is open source, it's on GitHub. We can see that code. We can also verify if that is the code which is deployed inside a canister or not. That's how we achieve this trustless environment. And then there are analogs to the mailing applications, the musical applications, you name it. And there is a need to port most of the applications from Web2 world to Web3 world as well. And that's where we are running these initiatives called as different hubs across the globe. And you guys are the potential ambassadors to spread the word and encourage more developers to create these Web2 apps on Web3, so that we have like the users can have ultimate autonomy in terms of how they interact with these dApps there. Now, how to build dApps on internet computer? This, me being a developer, this slide fascinates me a lot. I cannot, first of all, code on Bitcoin because it's not programmable. It has been programmed once and you just have to live with it. On Ethereum, you're stuck with a new technology called Solidity. You have to learn it. You can develop something, but only you could do some limited stuff there, right? Same is the case with Cardano. You'll have to learn some language. For Solana, you need to learn Rust. For Aptos, you'll need to learn their Move language. There are every blockchain is coming up with their own language, and that's good in one sense that the language has to be optimized for the blockchain itself. Similar things have been done by the internet computer as well. The most efficient, the most powerful, the most feature-rich language is Motoko. But then, not to limit the scope of normal developers, what Internet Computer has done is they have created multiple transpilers on top of Motoko. So if you're a developer in Rust, TypeScript, or Python, you could very well code in those languages. You might not have access to 100% of the feature, but I can be very sure about like 90 to 95% things you could easily be done in TypeScript and Python. So that's where you have like more scope for adoption of the internet computer blockchain, as students are very well aware with the TypeScript and Python in their college time itself. And then to help, we have a dedicated developer forum and dedicated developer Discord channel. I understand it's a new technology, only 2.5 years in the existence. You might not find a lot of answers on ChatGPT or on Stack Overflow. That's why we have the forum and the Discord link there. Yeah, perfect. Javier, would you like to cover from this slide the grant programs and other stuff?
Yeah, sure. Of course, we have two different developer grant program. Two different grants program on the Internet Computer blockchain. We have the community grants program and also the developer grant program. In terms of the community grants program, sorry, we have three different verticals. Is education, content, and events, and also another two that we add on top of that, that is for influencers and innovator in residence. We offer three different type of grants or amount is $5,000, $15,000, and $25,000. I suggest you go through the website. It's a community grants program definitive, and you can see exactly what is the KPIs, the metrics that you need to achieve, and it's pretty straightforward, the form. You just need to fill out the form, and also in ICP.Hub North America, we are sponsoring these applications. If you think you have something to bring value to Internet Computer in terms of events, education, content, or if you are an influencer in YouTube, in TikTok, or any other social media, please feel free to reach out to us. We are sponsoring now more than 20 community grants program in the last quarter in different events. For example, ETH Toronto, or also in Calgary University. Also, we cover content as well, different platforms on social media. But yeah, it's super interesting. I think it's one of the only ones blockchains that offer the community grants program, because other blockchains also offer developer grants, but not community grants. And I think it's an amazing opportunity. If some of you are interested to apply, or you think you have some value to bring to us, of course, reach out to us, and I'm happy to give you feedback about the application and see if we can sponsor or not. But yeah, this is an amazing initiative taken by the ICP hubs. All ICP hubs are working on this, on the community grants program. Yeah, and again, I recommend you go to our website and check community definitive grants, and also you can see the website about the communities, education hubs, and more information about us.
Perfect. All right, let's move forward. The key concept, the very last unique feature which we haven't touched base, is the chain key cryptography, and we do not have to dive deep into these terms. Let me explain you it very, very clearly. So Internet Computer has the capability to directly integrate with the Bitcoin and Ethereum blockchain. Right now, we have built the capabilities for Bitcoin. Ethereum is still being under the development. But what do I mean by Bitcoin integration? Again, let's take the example of trading Bitcoin with Ethereum or Bitcoin with any other token on the Ethereum blockchain. Ultimately, Ethereum smart contracts do not know what Bitcoin blockchain is and how to basically create wallet for Bitcoin blockchain, or even how to basically move the real Bitcoin on Bitcoin ledger via the Ethereum smart contract. What they have done is they have created a pegged token. They call it WBTC. You would have heard wrapped Bitcoin. Essentially, what does that mean is some centralized exchange. So for example, Binance will have the authority for you to give me the Bitcoin. In return, I'll give you a wrapped Bitcoin, which is ERC-720 token, a token which Ethereum can understand. And then you can trade that wrapped Bitcoin with real Ethereum or other tokens on the Ethereum chain. And why is that so? Even if the smart contract stores the private key of a Bitcoin wallet, there are two fallacies to it. First, since it's a public ledger, so everybody will have access to those keys. That's why it's not secure. Second thing is, even if the keys can be stored in the Ethereum smart contract, Ethereum does not have any capability to interact with the Web2 world, right? Ultimately, you need to make a call to an IP address somewhere to interact with the Bitcoin blockchain. Ethereum does not have that capability. That's where, with the HTTP outcall functionality and the private state of the canisters, Internet Computer was able to achieve the direct Bitcoin integration. So essentially, your canister can hold the public and private keys for a Bitcoin wallet, and that is how, like, if somebody transfer 10 Bitcoin to that particular wallet, essentially those Bitcoins are not owned by me, Javier, Internet Computer. No, those Bitcoins will be owned by that smart contract. And then you can program additional things around that smart contract to, hey, how can I call that smart contract to move that Bitcoin from one address to another, right? And nobody will eventually have the access to those keys. The good part is you could create games on Internet Computer where you could charge customers in real Bitcoin. You could create exchanges on Internet Computer where you could give customers the ability to trade different tokens with real Bitcoin. And with new Ethereum integration coming into picture, you'll be able to access Ethereum smart contracts, all the ERC-720 tokens, Ethereum NFTs, and your canisters will be able to hold the real NFTs on the Ethereum chain as well. So that's the advantage of the HTTP outcalls and the private state of the canisters. You have a direct Bitcoin integration today. Now you'll ask me, hey Ritvick, what is CKBTC? Now, rather than letting user move the real Bitcoin, right? Because moving the real Bitcoin on Bitcoin Ledger costs you a lot of money. Doesn't depend on the amount of Bitcoin you are moving, but let's say for if you have a game where you would want the Bitcoin to be moved between multiple wallets 1,000 times within 1 hour, it will be very inefficient on Bitcoin blockchain cost-wise as well, and also in terms of the time, right? Because if you move one Bitcoin on the Bitcoin ledger, it takes around 30 minutes to 40 minutes of time to verify that block. That's where Internet Computer has the concept of CKBTC. Hey, bring your Bitcoin to the Internet Computer. It will be stored within a smart contract. Nobody will own it, not Binance, not Coinbase. It will be within the smart contract will issue a CKBTC. Now, the CKBTC will be a token recognized by the Internet Computer blockchain, and this you can move very fast because of the transaction speed on Internet Computer is pretty fast, and the cost is too low as well. So that's where we have the CKBTC in existence here. And similarly, we have Ethereum integration coming up. Developers are working very hard, but this will also be achieved by the core two principles, right? The HTTP outcall functionality and the private state of the canisters. Now let's look at some of the industry standard reports here. I understand this slide is pretty old, but consider this. Internet Computer, the growth in terms of active developers has been increasing, and Electric Capital is one of the companies which basically monitor which blockchain, how much development is happening within those blockchain. The good part of the blockchain is all the development which happens has to be open source, and that's where companies like this basically can easily track where the active development is happening in which blockchain. These are a few more reports where ICP was quoted in top 50 by some of the bigger players in the ecosystem. And then ICP has also made its way into different governments as well. So Federal Italy has already integrated with the ICP blockchain. Why? They needed some sort of certification for the products within those countries. And they also wanted the assets, the images, the videos, the content of those products to be hosted 100% on chain as well. I consider these as some of the big initiatives when government basically realized the potential of a blockchain. Pretty sure the project is headed in the right direction. And I cannot disclose some of the confidentialities here, but there are multiple other European countries as well who are looking to bring more of their governmental products 100% on chain. And one might ask, what's the Definity Foundation? It's a not-for-profit organization which has spun up Internet Computer into existence and which actively takes care of the development, the improvement, the modifications of the Internet Computer we have today. If you would want internet computer to have some of the feature, what do you have to do? You have to just get some ICB tokens, lock it for 6 months. That will give you the ability to create proposal and participate in the governance as well. And if you could influence all the stakeholders of ICB today, the proposal will be accepted. Once that is accepted, the foundation, not-for-profit foundation, will take care of development of whatever the ask that proposal might have. And also, I've seen this particular foundation is the most reputed and educated foundation, I would say. It has the most number of PhDs and the researchers who have been crunching crypto for most of their life, and many more patents also they have in comparison to other blockchains. And Dominic, you guys would have already known him. He is the key person, the chief scientist who initially thought instead of Bitcoin, Ethereum, many more initiatives which were happening during that time, there is a need for an internet computer or a world computer, which we have today. Thank you. Any questions? All right. So if anybody of you have any questions, you could either reach out to me directly on LinkedIn or to Javier, or even in the forums Discord channel. You can post your questions there, and I'm pretty sure somebody from any of the hub, the foundation, or from our side will respond. Javier, back to you.
No, thank you so much, Ritvick, for your presentation.
Thank you.
And again, yeah, thank you, Sijin, for organizing this event in your club. Hopefully, next clubs also here now in November we have another events in different universities, and yeah, let's keep the ball moving and rolling and start to like do more events like this. I think it's so important for us create awareness about the internet computer, and again, the goal is also prepare hackathons in the future in these different clubs. Of course, we have the Discord channel. If you have some questions, please reach out to us. I know Sijin also shared with you the different courses that we are offering in TypeScript, in Python, that we will start this Friday. And also we have an education course starting 14th November. Yeah, thank you so much, Sijin. Not sure if we can wrap it up, or if you have any other thoughts or any other question. Okay, I cannot hear you, but all good. Okay, perfect. Yeah, thank you so much, guys. Also, the other ambassadors that are here, Nova, Sarah, Yiyang, thank you so much for your time, and all the people that are in the room. Yeah, see you soon. Bye-bye. Thank you.
Thank you. Have a good day.
Bye.
Bye.